All right, ladies and gentlemen. Oxidation of alcohol, big finish. So what do we have here? We have hydrolysis, the opposite of condensation. I think we had that one on our last one. Same comment. This time we're starting with a primary alcohol. I want to point out that our previous example was a secondary alcohol. And the result, you don't have to copy that, when you're done, was a ketone. So that's one thing you have to know for sure. And you have to be able to do that whole mechanism on that screen. Right there. If you have a primary alcohol, I'm going to tell you the big story and then tell you what parts you are responsible for, okay? So primary alcohols, it starts off with a similar story. Same mech as previous page is what I'm going to write here. Same mech as previous page. Same as previous page. This is called hydration. You won't do this mech on test 4. And I put a comment, here's the deal. I'm gonna make that a big asterisk with an exclamation. So star, that's a star, and a star. Is it clear? I might make you do up to here, same mech as previous page, same mech as previous page, and stop there. But I won't be testing you about an aldehyde becoming this thing called a hydrate. That's an aldehyde, and it is not a final product. How do you know it's not a final product? Well, there's more stuff after it, but what does the square bracket mean without the telephone pole? Square box, no telephone pole. Don't say it's a transition state, that's with the telephone pole. Those are at the top of a hill. At the bottom of a hill, between hills, like a carbocation could be there, between hills. They're called intermediates. So I'm just guiding you through the intermediates here, but I didn't do the mechanism because you'd be doing a lot of the same things twice. Making the second chromate ester is the same mechanism as the first one, so why would I have to test you on that twice? And so, but the result you are responsible for, you did not end with this aldehyde. What did you end with? It's right here. What is this functional group? Because that's what a primary alcohol will become during an oxidation with chromic acid. Carboxylic acid. Okay, you are responsible for knowing primary alcohols under these conditions. And when I say these conditions, these are the chemicals you've got available. You've got water, you've got sulfuric acid, you've got chromic acid. You're going to get a carboxylic acid. If you start with a secondary alcohol, you're going to end with a, what functional group's right there? Ketone. Got to know that. And I know I've done a lot of writing. You didn't have to do any of this writing. Sorry, he tells you now. I apologize. We're going to do our own kind of oxidation review and fill in the blanks. This is where I was going to have this done for you ahead of time, but 5:05 rolled around and I didn't get to it yet. So you want the primary alcohol summary? Primary alcohol. Here's your generic primary alcohol. Copy all of this, please, with okay? If you react it with CrO3, H2SO4, and water, you're going to get this. Because this set of chemicals makes chromic acid. You have to know that. This same set of chemicals also makes chromic acid. Looks very similar. Two out of the three chemicals are exactly the same. Highlighter, yellow. Also makes chromic acid. They're interchangeable, those two methods of making chromic acid. You need to know them. And what functional group did you end with on this molecule? Carboxylic acid. We should do functional groups in, I started in green. Now we're almost finished the primary alcohol story. There's a chemical that will let you make that into an aldehyde, but it cannot have chromic acid in it. It's a different chromium. Here it is. It's got a chlorine on it. Oh, and it's a chromate ion. And it's got this species here. It's called PCC, which stands for pyridinium chlorochromate. PCC. PCC. And it lets you make an aldehyde. You're not responsible for the mechanism. Chemicals only, not the mechanism. So I'm thinking this is roadmap stuff, right? If I had this as an empty, could you fill in what's over the arrow? Or if I had what's in over the arrow, could you give me what's the product? Those are the two big things on roadmaps. If I gave you one of these two things, could you predict the product? Or if I gave you this and the product, could you give me one of these two things as the blank? And then secondary alcohol stories, much more unified and simple story. Secondary alcohol, R prime. And I'll just summarize this one with a big old arrow. You tell me what functional group we got at the end. This one right here. Carbonyl with a carbon on each side. Ketone. This is a nice way to make ketones. You should be starting lists or pages with, on a page, all the methods you've learned to make ketones. And be ready to expand this page. On another page, all the reactions you learned that make alcohol. On another page, all the reactions you learned to make aldehydes. On another page, all the reactions you've learned to make carboxylic acid. Because we're building an arsenal of reactions to use in Chem 242. We have to have them organized by functional groups. No matter which chromium you use with this secondary alcohol, you get that result. There are 3 chromiums on this page. I'm going to copy them all. Instead of the all the red stuff, I'm just going to write PCC. Or purple. I already had purple. CrO3 and H2SO4 AQ. Is it clear that's the same as what's in the pink highlighter? CrO3 H2SO4 AQ is water. Or if you choose this set of chemicals, K2Cr2O7, H2SO4AQ. No matter which set of those 3 you choose, you're going to get a ketone. And the easiest story of them all, tertiary alcohol. R, OH, R prime, R double prime. Same result, no result. And easy way to remember why. Easy way to remember why. How many H's are on this carbon right here? How many H's are on this carbon here? 2. How many new bonds to O did you get? 1, 2. How many H's are on this carbon here? 1. How many new bonds to O did you get? 1. If you have 0 bonds to H here, how many new bonds to O do you get? 0. So however many bonds to H you have is how many bonds you're going to react if it's a chromic acid situation. If you want to make it less than a chromic acid situation, you better use PCC because it only reacts 1 time. This only has 1 H to react. You only get the 1-time reaction. And we're going to stop that share. No H's, no reaction.